Let's do another related rates problem. This is actually one of my favorite problems. You probably have something like this on the test or the final, we'll see. So what we're given is this. Water runs into a conical tank at the rate of 9 cubic feet per minute. The tank stands point down and has a height of 10 feet and a base radius of 5 feet. How fast is the water level rising when the water is 6 feet deep? So we're going to need to draw a diagram, obviously. So we have a conical tank with it point down. So probably what they have are some fasteners, to keep the tank from tipping over. We won't be concerned about those details. That's not our problem, okay? So water runs into a conical tank at the rate of 9 cubic feet per minute. That's a change in volume. That right there, that 9, that's a dV dt, right? Change in volume. Now, by the way, what is the formula for the volume of a cone? You're in Calculus 1, you're technically supposed to know that, but I'll give it to you. It is 1/3 pi r squared h. We're going to use that in a minute, okay? Now, the tank has a height of 10 feet and a base radius of 5 feet. How fast is the water level rising when the water is 6 feet deep? So the water is being pumped into this tank. Okay, and it starts to fill up, right? And what we're concerned with is that instant when the water is 6 feet. This is 10 feet, that's 6 feet, okay? So what, again, is being asked for is what is dH dt? So we're given dV dt. We're asked to find dH dt at this instant. Now we have a slight problem here because the right-hand side we have two variables. So I need to get everything in terms of h. So what I need is I need to get r in terms of h. So it should not be a problem. There are a number of ways you can do it. Notice that we have a constant slope here. So what we actually have is a linear relationship between r and h. So what I know is this. When r is 0, h is 0. That's at the bottom, the point here. There's no radius and the height is 0. Now when r is equal to 5, h is equal to 10. See up here at the top, the height is 10, the base radius, which is at the top, is 5. So, it takes only 2 points to determine an equation of a line. So, what we have here is this r is actually 1/2 h. You can check that. What is 1/2 of 0? 0. What is 1/2 of 10? 5. So what we're going to do at this moment is I'm going to replace r with 1/2 h in this formula. So now what I have is the volume in terms of h only. So I have 1/3 pi r, but what is r now? 1/2 h. So I have v is equal to 1/3 pi times 1/2 h, the quantity squared, times h. Well, 1/2 squared is 1/4. 1/4 times 1/3 is 1/12. So what I have right now is this. V is equal to pi over 12 times h cubed. Because I got r in terms of h, now I have the formula v is equal to pi over 12 times h cubed. Now I can differentiate. What do we differentiate with respect to? We differentiate with respect to t. Remember, both v and h are functions of time. So I have dv dt, which by the way we're given, right, equals, now I'm going to differentiate the right-hand side. So I'm using the power rule, it's also going to be the chain rule. So if I differentiate, I get 3 pi over 12, which is the same thing as pi over 4. So I have pi over 4 times h squared times dh dt. Right? So we're almost done. What was dv dt? We were given that, weren't we? That was 9. 9 is equal to pi over 4 times h squared. Well, the moment that we care about is what? H is equal to 6, right? When the water is 6 feet deep. Well, what is 6 squared? It is 36. And then all of this is going to be times what? dh dt. Well, 36 over 4 is 9. Divide both sides by 9. So I get 1 is equal to pi times dh dt. So we have our answer. dh dt is 1 over pi, and our units would have to be what? Feet per minute. So at this instant, the height is increasing at a rate of 1 over pi feet per minute. So to give you an idea, let's see, what is 1 over pi? It's about 0.318, okay? So a decimal approximation, 0.318 feet per minute.